Everyone, welcome again. Let's get started with Dockerizing. Our today's topic is Dockerizing. It means that we want to understand that if you have a software, a piece of code or something, right? You want to run inside a container, then what are the steps you need to know? You need to understand Docker image, etc. Right? So the topics we want to cover today is the first one is that what is Docker image? Second, we want to understand that what is Docker image registry, because if we build the images, we need to place it somewhere in a version controlled way. We will try to understand what is Docker image tag, and we will take the latest tag example also, that what is latest tag and how it is differentiated between the different version tag and this one. And then we'll try to understand that how to build a Docker image using Dockerfile. So obviously, while explaining, I will be talking about the Dockerfile components, various component which we can use in Dockerfile, and then we can run it. So another is that what is Dockerfile and its component, right? Then we'll try to understand the multi-stage Docker as well, multi-stage Dockerfile. So at the end of the day, at the end of this topic, when this video is over, let's say, you would be able to demonstrate your skill in building Docker images for any of the use case. Let's say for Node.js images, we will take and combine multiple examples also, right? Python, Java, and others. Okay, so let's get started. First, we'll try to understand what is Docker image. So a Docker image is in previous video of, like say, while I was explaining about what is Docker container, then I said that container is a uncompressed form of Docker image. What does it mean? Essentially is that Docker image is an archive form of environment. So we can say that Docker image is an archive, in my word, format of, apologies about the typos, archive format of container environment plus the code. And obviously, what is the container environment? We know that container environment is where your OS, libs, libraries, binaries, etc. would be, right? Along with the code runtime, libs, and bins. What does it mean? That if you are, let's say, trying to run a Java a Spring Boot application, then the Docker image, you will be selecting something where operating system related minimal libraries binaries would be, and then there should be the Java OpenJDK version installed, so that if you have Java OpenJDK version, then only your jar file or var file can execute or can run, right, with the Java command. So this is the minimal requirement. Now we'll try to understand that what is the base image concept, how the images are we are creating. So far you understood that container is unarchive, or container is the extract form of Docker image, and Docker image is the archive format of container environment, right? It's a, and what is container environment? I told you that operating system. So container environment is same like operating system is also there are multiple directories and files, right? It starts from slash, and in the same way the container is also starting from slash. There will be multiple files, etc., in directories, etc., in that environment. And then let's say if we are making kind of archive, then that becomes our Docker image. So that is one. Second, what is the Docker image registry? When your image is ready, you can build your custom images also. You can build any custom image alongside of your code, and then the base image you can use. So we will try to understand the concept of base image first. That what is the base image? I'm speaking about the base image, right? What is the base image? So it's not like you can start building your container image from the scratch. No, you can't. You need something like a base. So if I say like, excuse me, you love pizza, fine, but it's not like you are bringing up your own pizza toppings based on your convenience or what you like most, right? Lot of cheese, lot of corn, um, uh, paneer or something, right? It's up to you. So, but still you need a base. Now, base is something which, let's say that, assume that you cannot prepare pizza dough. That's a base. You cannot prepare. That has to, usually people, what they are doing is that pizza dough is are available ready-made into the market, right? So if you get a pizza dough one, you can you can put any of your choice topics there, and based on those toppings you can cook or bake the pizza, right? Maybe veg materials or anything if you love non-veg. So that's how the base images are also. Okay. So now if I talk about more about the base images, then let me say that how the companies are publishing their softwares. Let's say you want to use a software, and the software vendor company will be publishing that software, obviously, right? At certain place in their website maybe, so that you can go ahead, browse their website and download the software and start using it, right? Get installed in your laptop and start using it. But what did you understand is that the software they are publishing on their own website, and there would be several software publishing, there will be several software components, softwares which are specific to Mac OS, specific to Windows, or specific to Linux only. But you want, let's say, on Windows or something, so Windows, Mac OS, or Linux becomes your platform. For that, the software companies are publishing. So I'm giving you an example. Let's say MariaDB, right? MariaDB is a database software. If the company MariaDB Foundation, right? I'm going ahead here. Let's say MariaDB. So MariaDB Foundation is a company behind MariaDB software. So if MariaDB Foundation is releasing a new version of their database software, MariaDB, right? If you click, they will be giving you, they will be publishing the new versions at their website. So this is their website. If you click on the here the download button, you will get to know that the MariaDB software, this particular version or any previous version or whichever you want, let's say the stable version 11.4.3, if you want, then you can download, but then you can select which operating system, Windows, Linux, and all, right? What are these? These all are the platform. Fine. Now, these all are the platforms for which you can download the MariaDB software and you can run it. But when it comes for a container platform, right? Container platform where you want to run MariaDB, okay? Or if I'm giving, let's say, example of MariaDB, fine. We will talk about the base OS images also. So what MariaDB is doing, they cannot publish here the Docker, because Docker container runtime interfaces are universally single interface which they accept. It means that it's not like you will download your Docker image straight away from any of the publishing vendor website, right? That software vendor website, if they are publishing on their own website. No, it's not like that. So there is a marketplace of Docker images. Okay, there are few. Okay, so I'll predominantly talk about one, that is Docker Hub. So if I open, let's say, Docker Hub, dockerhub.com. So you'll see that this is a website. Docker Hub is a website. This is actually a marketplace. In this marketplace, everybody, any software providers are create, whenever they are publishing their new version of software, their containerized form of that software they are publishing at this place. This is a marketplace. Now let's say I I opened up here MariaDB server 11.4.3, right? So what they do, they publish at this marketplace. Now I want to search, or I want to look for the MariaDB, right? So I will try to look for MariaDB here. And if I look for MariaDB, you will see that this is a MariaDB server, right? There are many others also. I'll talk about them and why these badge, Docker official image badge, and then here's a verified publisher and another thing. So MariaDB, if I click on this place, right, you will see that they have published 11.6.1, 11.5, 10.11, right? And 10.5.26, 10.5.26. So these all are the different version tags which they have published. MariaDB Foundation has published in a form of container. So if they have already published it, right, you don't need to install. You don't need to download these images. What you can run is, you have seen in my previous video where I was talking about the container image, and then when I was running docker run command, what it was saying, it was doing is that it was checking locally if that image is available. If that image was not available locally, it was trying to download from some place, right? This is a place from where it was trying to download. Docker hub, docker.io. This is a place from where it will look out of the box, and it will look that image available or not. If the image is not available, it will not download it. And if the image is available, it will try to download that image, right? You don't need to worry about if the image is available or not. So if you try to check here 11.4.3 and see here if 11.4.3 is available or not, right? So you see that 11.4.3 has been published here, and that's probably the latest and greatest version. Even 11.5 also, Noble, UBI, and others, which you can see in at this place also. Okay, so it means, first thing first, what you will try to understand here, you understand that Docker Hub is a marketplace. Okay, all the software companies, when they are publishing or releasing their new software, they are their software containerized format or container image, so that you can run at Kubernetes, you can run on top of the Docker, you can run on Podman or anywhere, right? Then those software companies are publishing their container images over here at this marketplace, so that anybody can pull Docker images and start using it. Fine. So if you see here, you will find out the command also, docker pull MariaDB. So just for giving you a small example, if I'm going ahead here in my Docker machine, Docker lab machine, right? And if I run docker image list command, you will see here that Alpine Nginx, fine. Now if I want to run this command, that command which I had, docker pull MariaDB, and fm, what do you see here, that there is a default tag latest, and you see that the image was not available, and that's how it started pulling from library MariaDB. It means that the image is actually coming from, see here, docker.io/library/mariadb:\latest. Now I will try to break down that what this URL means, right? Because this is a public marketplace. In your organization, you may have a private marketplace as well. So let's talk about the registry more here. Okay, so let's break down this. So any point in time for any Docker image URL, okay, so if you want to pull any image from a private registry or from a public registry, you can give the complete path of that image. Docker.io here is equals to, what is it? This is your registry. Now what is registry? The marketplace. And what is marketplace? Again, it's a software where which you can install at your own place also, and you can start pushing images, right? Pushing both. So registry is required. It's like artifactory, right? It's like source code management system. You can use GitHub also to push your code, okay? Version control management, right? And at the same time, you can install your own Git server or Git software at your own place, right? And there also you can start pushing it. So you can use GitHub, you can use uh, GitLab, you can use any public, or you can host yourself as well. So docker.io is basically the registry server. It means that this is that particular marketplace where you can pull and push images, you can publish images, etc. This is a public one which is available for everybody, right? You can also create your images and push it here. So docker.io is equals to registry server. Now the slash library section is talking about the space, or we call it as namespace or project. This is a namespace or project, okay? And then at the end, what is MariaDB here? MariaDB is your container image name. Okay. And what is latest? Latest is a tag. This is a tag or version. Okay. So if let's say I'm giving you version example here. So we want, instead of latest, we want to download this particular version 11.2.5. So how we will download? The same command we will run, just we will add the tag. Okay, so tag we want 11.2.5, we will write 11.2.5 and then I hit enter button, press enter button. Now what you see here, that it started pulling the image 11.2.5 from library MariaDB. And if you'll see here right down the line, you will find out that now when I precisely given the tag here, right, then it started pulling that precise version of MariaDB image. So what if you run Docker image list or Docker images? You see that you have two different version of MariaDB software, and here you see the image IDs are different. So you have two different version of MariaDB. One is the latest version, another is the 11.2.5. The image IDs are different, and here you can also see that when the software provider has published their images, what is the size of this container image as well, right? So here you can see. So that was the image detail. Now talking about the private registry. Okay, so private container registry you may have in your own premise. So container registry you may have at your own place. So there are few private container registry applications or software, enterprise softwares are available. There are few, we call them as CE, the community edition, which you can also install at your own place. Okay, you can install them for a lab purpose also, and then you can use them for your lab purpose as well. I will try to install one and I will try to tell you that how you can use it. Okay, the first one is Harbor. Okay, VMware Harbor. Now let me take you to the page VMware Harbor. So if you look for VMware Harbor, this is a project by VMware. This is a registry. So here you see trusted cloud native repository for Kubernetes. What is Harbor? Harbor is an open source community edition free registry that secures artifact with policies, role-based access control, a lot of things in Harbor there would be. Harbor installation and configuration method also if you see, then there will be installation method, multiple installation methods are available, right? So that we will talk about later on any point in time when we'll try to install this Harbor on Kubernetes or somewhere else, and we'll talk about the Harbor, right? So Harbor is a registry. The another registry is, which is very easy to install and use also, right? That is registry 2. What is registry 2? Registry 2 is, sorry, registry v2 Docker. Docker is giving an open source registry v2. So if you click on this link, right, you will see registry. What is registry? It is a distribution implementation for storing and distributing of container images and artifacts. You can run this as a container, and inside that then you can start utilizing it as a container registry where you can publish your container images, etc. Okay, so fine. So now let's try to understand that here. What are the other options? So enterprise edition softwares also we have available. One is the JFrog registry. Okay, the another you might have heard about it, Sona type Nexus. Okay, there are various other registries also, Red Hat Quay and others. Okay, these are the private container registry. I forgot to talk about the public registries also, public container registries. So the one is like GHCR, GitHub Container Registry. Then you have git docker.io. We call it as Docker Hub. You have que.io, which is by Red Hat. Okay. You may heard about gcr.io, which is Google Container Registry, right? Some public cloud providers are also providing their own registry, managed registry. Okay. Docker.io is something which you can use. Public container registry, private container registry. This was all about the container registry. Okay. Now, if let's say, and I'm going to tell you the method of how we want to build the container, so that then I will talk about these things. So let's go to the next topic. Image registry. What is Docker image? You understand that, right? I have downloaded that image here, so you can understand these images, and if I want to run any of them, I can run. All right. So what is Docker image registry? We understand that. What is a Docker image tag? We understand that we have whenever you will be publishing your image. If you want to publish your images, then you can uh, give a tag, and that tag will be presented as image. So the image name will be same, but tag you can give different based on what version you are publishing. So today if you are publishing, let's say I'm giving just an example, um, for this URL, right, which I just explained you. So in enterprise, let's say you have one, you are working in a example.com company. So you may have reg.example.com, and then here, then you may have your own name as well. Let's say Vijay slash, and then you may have my web colon v1. If I'm writing like this, it means that reg.example.com is my registry software URL, right? My registry repository, I mean the registry software URL. Vijay is the namespace or place, okay, is a namespace or repository where we can place our images. So we can, if you have different repository names, we can place the same images as well there. There is no problem, right? That's how we do the segregation. My web is the application container name. Okay. This is app container name. And then colon v1 is your tag. The tag or version of my app container image. Fair enough. So going forward, let's say you have published today one change in this image. This is a let's say Nginx image, a web server image, where you are just printing hello world. Now tomorrow you wanted to print hello world, I am here. So that will be a changed. It means that you are putting next code, extra code there. You are doing code change, and after code change, you want to package that code change into a container format. So that will be your version 2, right? So anybody is, let's say, running. This is a version controlled method of container images also. Your hello world code has logged in here in this version. Hello world I am coming is logged into this image. So let me give the example as well. Let's say here you are printing hello world, and here in this image you have printed hello world, I am here. So if anybody will be deploying your this container image and uh, accessing their container, they will be getting printed as hello world. If somebody is using version 2, they will be getting printed as this. So you are essentially making your code also version controlled with help of container entirely. But the major benefit of container images are that one image, if it has got built with set of environment and everything is available, the same image cannot change its behavior if it is running on a different system or different platform. So if this particular image, let's say my web v2, if I'm running it in my own Docker machine, it will print hello world, I am here, there will be no change. If I'm running this image in a Kubernetes platform, let's say Red Hat OpenShift, it will be printing the same thing without any problem, and it doesn't require any dependency or something because everything is managed and it's packaged inside the container image. We have baked that image, right? That's how it works. So if we deploy on Docker Swarm cluster also, it will behave same. It will print only hello world, I am here. Will be no deviation, not even a single dot. That's a benefit of packaging your software into a container, and then that container is platform agnostic. When I say platform agnostic, it doesn't mean that your container can run on your native Unix platform. No, it requires a Docker or a kind of similar runtime, container runtime interface so that it can run on top of that. But container platform agnostic, we can say, so that it means that it can run on Docker, it can run on Docker Swarm, it can run on Red Hat OpenShift, GKE, Azure Kubernetes Services, or maybe EKS, Elastic Kubernetes Services, Oracle Kubernetes, or any Kubernetes around the globe, right? Whichever this container image can run. All right, so we understood about the image versioning and tags so far, right? I will try to build all of these things when we'll try to understand the Dockerfile in next. So now let's try to see that how people are building Docker images using Dockerfile. Before that, let's try to understand one more last thing from the image, right? The base image, okay? So we will try to start writing from the Dockerfile also here. So if you want to, let's say you have a code, HTML code. You want to run this HTML code. You want to package this HTML code with a web server. Web server is your environment to run this HTML code, okay? And your HTML code can run only with the web server, right? And that web server has to be part of the container image. So it means that you need any base image, container base image of Nginx or Apache or something, web server. You can use that and you can package your code into that image, create a final application image, push it into the registry or locally itself, and then start running it. The image uh, will run as a container. It will print, run a web server also. You can browse it and it will print all your HTML content will be accessible like a web server, right? But question is how it works. It works like this. If you have Nginx, right, then on top of that you want to package your code as well. So it means that you will write all of these instructions line by line, and line by line those instructions will be executed to create your final application image. It is like a script, shell script, where you want to achieve some target and you are writing all your script line by line. The script will be executed, all the tasks it will execute, right? So Docker file is the method where we are defining what we need in my final image, and with help of the Docker file, when we execute it with Docker build command, my final image will be built up. Let's try to see the Docker file. Docker file, the name is T capital and then Docker file. So I'm giving you a small code example here, right? So in Docker file, there are several defined arguments we use. Okay, the first thing is we use from in capital and then give space. From means that first statement from means that we are defining that, hey Docker, when I'm building image, I want that you use a base image from. Okay, so here in from we can give any URL. Let's say base image I'm talking about. So I can give like docker.io slash library, okay, slash nginx colon latest. So this will be always, from will always be the first line of your Docker file because it will execute in sequence, right, from top to bottom. So from, you are mentioning that, hey Docker, I'm trying to build a container image, custom container image. For that, you use a base image as docker.io, download from here, from library repository nginx, and give a latest tag. If you don't want latest, you can use 1.24 or something if it is available. precise version as well, as I mentioned earlier, right? And then what you want to do, you have a code where in your current directory, okay, then you use command copy, and then copy, you give source. In your source, let's say you have index.html file, which is in your current directory where your Dockerfile also exists. What will be the directory structure? Let me talk about the directory structure here. So directory structure will be like, this is my slash, and here I have one file as Dockerfile, then and I have another file as index.html. Okay, so this is, let's say, your code place. You may have multiple other files also. If you have multiple other files, what you can do to copy all of them, if you have individual file, you can write like this. And what is the place of Nginx, where what is the document root? It is usr share Nginx and webroot or htdocs, whichever we said. Okay, so to check precisely the path, I need to run a Docker container of Nginx. So let me run it. Docker images. I have Nginx image. Yes, here 1.22. So I will try to run it. Docker -rm hyphen hyphen exec hyphen it nginx colon 1.22 and then sh. What this command will do, it will run uh, a Docker image. Sorry, exec I don't need to give, and before that I need to give Docker run. So it will run a Docker container image. It will take the interactive terminal also. It will run shell script inside that. But -rm switch, what it does, when the container will be created and I will be into the cell, but when I will exit from the cell, the container will be automatically removed. So here, right, I'm inside container bash. Now if I go ahead here in etc nginx and try to see in conf.d cat default, then we see, I'm just trying to see the document root. Document root is this. Okay, so this is a place where I need to place my index.html. Okay, so I'm just doing exit, the container will be deleted. Okay, now this is my current directory. Let's say mkdir docker file. I'm creating a directory docker file, cd docker file. Inside this I am, let's say, creating one file index.html. Inside index.html I'm just writing this hello world for you. Okay, and closing the tag. This is my code, for example, right? You may have Java code, you may have Node, JS scripts code, etc. Now I need to write a Docker file. So first thing first, I write in Docker file is from, we all know. Then I write nginx 1.22, right? Then what we write? Copy. What I want to copy? Index.html. At which place? At this place. Okay, this is a folder. Inside that I want to copy index.html file. I can give precise index.html path as well. So this file will be copied with this name. Okay, next is that because nginx has port 80 already, I don't need to provide expose or port 80 or something. I will talk about the other parameters also for this Docker file. I don't need to provide that. Now what this command, now Docker build I have to do, right? So let's save it. I have mentioned two parameters only. Now what I want is that I want to build it a container image. So let's see that when we are building, how we are giving the version, etc., right, and the name, etc. So the command you will use here is docker build -t will be used to give a tag, and with t, not only the tag you are giving but the name also. So complete name you have to give. Even if this image you have to push in your registry, then you have to give the complete registry path, repository, image name, colon, tag, all. But if you don't want to push into any registry, then you can give any name. Let's say I'm giving web app colon, and then I'm giving v1, right? And then what you need to give is dot. What dot represent is, it represents that look a Docker file in my current directory. If let's say the Docker file name is different, then you will give -f dot, still you will see that where it needs to check, right? Current directory should have Docker file, and then -f, then you can give different name if you have the file name different. I'm giving dot, and then what I'm doing is I'm pressing enter button. Let's see what changes are being done here. Done. So what do you see here? There were two different steps. You see here, right? There were two different steps with what I have mentioned. First step 1 by 2, that is from Docker IO library Nginx 1.20, right? Right. That's how it takes this image. Then it copies the index.html into this like this. Then it's exported to the image, right? Exported the layer. Okay. What is the image layer? That we will try to understand later on. Okay. So here, if my image has been created, how? With this name. So if I go ahead here in Docker images command, if I'm running, what do you see here? You have web app. Now see, I used Nginx 1.22, which has image. I did this, right? On top of that, what I do, I uploaded, copied my index.html, and then I created another image, web app, and tag was v1, and image ID gets changed. Why? Because the checksum value and everything for that image has got changed, and it has one new addition also. That is the reason 39-second back we have created this container image. So since we created a container image successfully with a Docker file, right? Now, if I want to run and I want to see if the content is coming in or not, right? So let's try to run it. Docker run -d and -p hyphen name test web1 web and -p port I want to expose on port 8080, and then the web app colon v1. So I run it. If you see Docker PS, you will see that you have other containers also running. That's fine. Port 80, I have never exposed for this test CPU and test. So I have only this one, the web, and it's running on port 80. So if I go ahead here and try to look for my Docker container image host 192.168.1.50 only, and then I press enter button, you see you are getting hello world. Very good. Now let's say you thought that, hey, the code has got changed because customer has a new requirement. So you open up your code index.html. Now you mention that, hey, the customer has a requirement that it should start printing hello world, and then I am coming. So you're writing I am coming. Fine. Then save it. Now what you can do is you have to build a container image, right? You have to package your code. You have to bake the container. So you can run again the same Docker build, but this time you will give a tag as version 2, right? I'm doing nothing, just giving the next tag, because so that I can show you how when I'm running the container v1 and how I'm running the container v2, how the changes are behaving, same as I gave into the theoretical example. So when I'm running this, what do you see? Same command is running with the two different steps. Now it's copying index.html, and I have, if I run Docker images, what do you see here? That I have two different versions of web app and two different image IDs as well. So web app v1, web app v2. If I run Docker ps, right, and I have one this uh, container image, right? So container. So I will stop this Docker stop web, and I will run again Docker run command, and will give web v2 as a name, and here also I will try to run web v2. Enter. My container is running. So when I go ahead here now and try to refresh, it's giving hello world, I'm coming. That is version 2. Why? Because I just run a container with version 1, version 2, right? So this is how we containerize a very simple container and very simple image, right? So now you have a fair enough understanding that What is Docker image? What is Docker image registry? What is Docker image tag? What is Docker image using Dockerfile, right? We will talk about the Docker image file uh, content, what are the multiple other components, etc. What is the multi-stage Docker file in a later second part of this video, the Dockerizing. This was the first part. All right. Before we move on, um, this Docker, how I'll tell you that how we push this image into the Docker registry. Okay. Let's try to build a Docker registry for us so that one Docker registry, if we run, if we deploy, then at least we would be able to see that how someone can use Docker push command to run. Okay, so we will try to run. So we will try to set up a Docker registry. I will show you some good things, some cool things. So what I'm going to do is, let's try to understand the structure. Okay, so mm, I told you that, okay, let me take the last example which I gave. This is, let's say, my bridge network. Okay, I have this container. So I'm just trying to modify here. What I want is, you see that container 1 is can connect to container B. And if I have this natted, it means that this if this person is trying to access the IP address of 150 on, let's say, port 80, right? Then actually this container content will be visible with the DNAT, right? If you haven't um, gone through the last video on container networking understanding, I would encourage to please go ahead and check that. What I want is that this container A, instead of this, I am trying to say registry web proxy. I want to use this a registry web proxy because by default, and this container, I want to create another container which will be my registry v2, because this registry v2 is actually working on port 5000. On port 5000, you would not be able to actually understand uh, port 5000, right? So that is the reason I want to uh, give you the UI port so that you can see all of these things, right? Or otherwise, let's not go on UI. Maybe we can try later on. So we will try to run a registry image like this, and we will try to expose this registry image on port 5000 here. Okay. And we will build image and then we will push in our local host container registry software. Let's try to run it. Okay. Fine. So how can I run it? How can I run the container registry of my own? So I can run like Docker run -d -p port 5000. I want to map with port 5000. The container itself is also running on port 5000. Okay. The name I want to give is reg or registry for this container to run, and the image I want, that image should be coming from registry colon 2.7. There is one version of 2.7. Let's try to run. It tried that registry.2.7 is version is available locally. It says no. So here, and if you see Docker PS, you find out that there is a container registry also running on 5000 port. The name is registry. I'll try to delete all the other containers. So Docker rm -f web v2 web test cpu. Okay, all deleted. Docker ps -a. I don't have anything except this registry, right? And but I have Docker images. If I run, then I have multiple images. What I can run is, let's prune all these images. So I will try to say Docker image prune -all. Why? This command will try to prune all the images which are not in use. So if I run docker images, we see that registry was in use because with this registry we have just created a container. Others were not in use, so those have been pruned. Okay, cool. So we have a container registry functioning on a local host. So if I want to build a container again, right? My what will be the this container registry address? Let's say my container image registry address will be localhost because it is in my localhost colon 5000. This will be my registry. So if I want to create a repository, I will use Vijay. Then if I want to publish, I will use web colon v1, web app colon v1. So I will, it means that the tag I have to create like this. So I'm just going here. I'll do a copy like this, and I'm because I'm there, right? Dockerfile index.html. So I will try to docker run a docker build again. This time the tag I'm not giving this name because otherwise it will not be able to push. I'm giving like this. Okay, now let's build. Now Docker images, if I'm trying again, we see that we have a local host image available. Okay, and we have registry here. That's one image, and we have this local host image available, which I have, right? Now I want to push it into the registry, right? But before that, we have registry uh, interface available, and we want to make sure that do we have any registry, any images already available or not. So there is a API command, right? This image we are able to push images and pull images because the registry interface accepts the API commands, right? That is how the objects we are pushing and pulling. So we can use curl, we can pass -x, we can use get here, and then we can use http colon slash slash localhost, okay, colon 5000 here, and with 5000 we can run underscore sorry slash underscore catalog. So if you run like this, it says okay, page not found. Fine, we'll try to see here. We need v1 as well, so I'm running here v1, v1, sorry, v2, because it's a registry 2, right? Yeah. So what you see here is in a JSON output, we see a repository, right? JSON output says that in repository there's nothing in my catalog. So I have already have image created, right? So this image this image I want to push now. So let me push that. The command is very simple: docker push and give the image name. You see that your image is now getting pushed, right? And when you run again this curl command, just to validate and see that do you have the correct images available, you see that you have one image which is Vijay web app. Earlier this was not available. Okay, so now if you want to see the tags of web app, right? And let's see that if I want to do a change and I want to publish another tag here. So index.html, and let's try to remove these tags, these strings, and let's try to build it again with v2, and let's try to push the v2 again, v2 as well, right? So push v2. So I have pushed v2 also, whatever the changes we had. Now if I try to run the curl command, right, with a catalog, we see still that same, but actually this image has two different tags. So if I want to see the tags, then the endpoint is different. The catalog will show you the catalog only. The other endpoint is web, the image name. What is the image name here? Web app, and then tags, and then list, right? So if I run uh, the error, something I'm missing, tags list, that's actually correct. uh, error repository name not known to registry. The name as a web app. Oh, sorry, I'm missing is that I have to write Vijay as well here. So when I'm writing here the repository name, right, that was missing, it was saying. So I am now mentioning the correct thing, Vijay, that's the repository name, then web app, the image name, and then the tags list. So we see here that for name Vijay web app, we have two different tags in a list, v1 and v2, right? So we can be sure that yes, our images has got pushed correctly. Now if I want to pull those images again back here, before that I can remove those images from here, right? So I'm going to remove them. Again I will run docker image prune hyphen all, and we see that those images have got pruned. But since we have images available here, I can pull it. But when I'm pulling, I can use the same docker pull, and from this registry. Now this time this image it will try to pull from here. So you see here I pulled it, and if I run docker images, you will see that the image is available with the same size and with the same image ID how it was earlier, right? You can see here, you can compare even the image ID as well. So 639b, 639b, right? So this was the final takeaway from here. We know that how registry works, how registry behave, how we can set up a personal home lab registry, and how we can test the pull and push functions here, right? With this, we are really good. Thank you everyone for watching. Please don't forget to subscribe, like videos. Yeah, thanks very much.